A higher operation with complex numbers is taking its power. With a rectangular form, taking power is the same as expanding binomials. But how about the polar form? Find it out here in Mathematics of Engineering. If we are tasked to evaluate 1 plus I raised to 6 plus the cube of 1 minus I less the square of 1 plus I, we can do so by simplifying each term. Break the solution into 3 parts corresponding to the 3 terms. First is 1 plus I raised to 6, which can then be taken as the cube of 1 plus I squared. Expanding the square, we get the cube of 1 squared plus 2 times 1 times I plus I squared. The last term is taken as negative 1, so the quantity becomes 1 plus 2y plus negative 1. Then 1 and negative 1 cancel out, reducing the solution into the cube of 2i. This can then be transformed as 2 cubed times I cubed, which accounts as 8I cubed that can be broken down into the square, which is negative 1, and then I. So 1 plus I raised to 6 is negative 8I. For the second term, the cube of 1 minus I, we can use Pascal's triangle, where the cube of the two terms would have the coefficients 1, 3, 3, and 1. Applying this into the term, there are 1 cubed plus 3 times 1 squared times negative I plus 3 times 1 times the square of negative I plus the cube of negative I. Simplify the terms and get 1 minus 3i plus 3i squared minus I cubed. I squared is negative 1 and I cubed is negative I. So the outcome is 1 minus 3i minus 3 plus I. That can be simplified as negative 2 minus 2i. The third term is the square of 1 plus I, which is 1 squared plus 2 times 1 times I plus I squared. The last term is negative 1, so the solution becomes 1 plus 2y minus 1. So canceling the 1's leave 2y for the third term. Placing all solved terms for the function, there are negative 8i plus negative 2 minus 2y minus 2y, which is then simplified as negative 12i minus 2. Rearrange the terms to keep the complex number format, so the answer becomes negative 2 minus 12i. If the solution for the power of complex numbers in rectangular form can be solved directly, what should we do if the complex number is written in polar form? Let's take the square of the complex number written in the standard polar form. With the term of the modulus and the argument, its square becomes r squared and the square of cosine theta plus I sine of theta. The binomial's square is then expanded as cosine theta squared plus twice of the first term cosine theta and the second term I sine theta, then the square of the last term I sine of theta. The solution becomes r squared times cosine squared of theta plus 2I cosine theta sine theta plus I squared sine squared theta. I squared is negative 1, making the solution r squared times cosine squared theta plus 2y cosine theta sine theta minus sine squared of theta. Rearrange the terms to fit in some identities, making r squared times cosine squared theta minus sine squared theta plus I times 2 cosine theta sine theta. Now recall from trigonometric identities that the cosine of double angle is cosine squared theta minus sine squared theta. And then from the second term, Note that 2 cosine theta sine theta is sine of double angle. So the square of z becomes r squared times cosine of 2 theta plus I sine of 2 theta. Comparing z with its square, one can easily note that there is a pattern, where if the exponent is denoted as n, z raised to n is equal to r raised to n times cosine of theta with n plus I sine of n times theta. This equation is what is known as the Moivre's theorem. Let's show some examples using the theorem. Determine the cube of 3 cosine 25 degrees plus I sine of 25 degrees using the Moivre's theorem. Z cube is the cube of 3 times the cosine of 3 times 25 degrees plus I sine of triple the angle 25 degrees. Z cube is then 27 times cosine of 75 plus I sine of 75 degrees. Another example is with z equal to 4.2 cosine of 4.10 plus I sine of 4.10. Note that the second example uses radians. Nevertheless, that will only matter if we compute for the rectangular form. So z squared is the square of 4.2 times cosine of twice of 4.1 plus I sine of twice of 4.1. Z squared becomes 17.64 times cosine of 8.2 plus I sine of 8.2.